Now, this part of the tutorial is not a new part, it's actually the continuation of part 4 where we were talking about integration by parts. The point of this part is to actually give you difficult examples that either need you to think something new or know some tips and tricks. If you cover this part, then you will be able to ace integration by parts completely and you'll have all the tips in your pocket. So the example we have here states that integration of x squared into 2 sec squared x tan x. Now, as you see, we have a combination of trigonometric functions, a trigonometric function and a polynomial. But as I mentioned earlier, whenever we have a polynomial, it's better to take that as your u because differentiating it reduces it. So here we'll have du to equal to 2x dx. And here on the other side, we're going to put our dv equals to 2 sec squared x tan x. Now, when you actually come across that, you want to remember your identities or your differentiations. And if we remember that, we said here that if we want to differentiate sec x, it's going to give us sec x tan x. Now, what do we differentiate to get 2 sec squared x tan x? That will be simply sec squared x, because by the chain rule, this will give you 2 sec x, and then you're going to differentiate sec x to get sec x tan x, so this will be sec x squared tan x. In other words, if you want to integrate this value, it's going to your v is going to equal to sec squared x. And by that, you're going to be done with this. If you want to write out your actual integration by parts formula, it's going to be u dv equals to uv minus v du. And if you want to replace these values, your u is x squared, sec squared x minus your integral, which is v, and your du is into 2x dx. Now, if you actually stop here, you're going to find that this is still not easy to integrate. But you will also notice that you still have a polynomial and a trigonometric function. But this time you'll notice that your polynomial, if reduced, will be reduced completely. In other words, if your u is equal to 2x, your du is simply going to equal to 2. And if you want to put the dv, or you have to put the dv, this will only be sec squared x dx. And this is very easy to integrate because you know that differentiating tan x gives you sec squared x. And then you reapply the integration by parts, uv minus v du, and oops, here. And if we want to write it out, this is going to be uv, so 2x tan x, minus our v du, which is in our case here going to be tan x, oops, yeah, into 2 dx and 2. And then after we write this out, we do not forget our final part, which is that x squared sec squared x. Here I need to mention something very important, which is the integration of tan. This I need you to memorize for now, because in order to know how to reach it, it needs calculus too. So let me just write it out for you. The rule is that the integral of tan x dx is actually equal to ln sec x plus c. Oops, let me go back. And plus c. There are even further rules that you can actually cross, which is, for example, the integration of sec x itself. It's going to be ln into sec x plus ln tan x, I suppose. I actually don't remember the rules now, but etc, etc. There are multiple rules that apply for the integration of these functions, but for now this is the one I need you to know in order to be able to replace your final value, which is x squared sec squared x minus, because here it's a negative, and this is 2x tan x, and this will become a plus 2 ln sec x plus c, and that will solve it. And this will be the first difficult question that I'm going to introduce in this tutorial. The second one is also a bit difficult, but let's just solve it. And yeah, I wanted to solve one here with the exponential functions because it's one of the ones the examiners usually like. So what is it? This one here, it's in, oops, yeah. We are given the question to be integrate e to the power x sine x dx. It sounds simple, but it's not, because ex just gives you ex and it seems to continue forever. So what we're going to do is ex can either be integrated or differentiated, but let's just differentiate it. So our u is equal to ex, and our du is going to also equal to ex dx. On the other hand, our dv is going to be sine x dx, which means that our v is going to be negative cosine x. Now if we wanted to write it out, this is going to be uv, which is our ex sine x dx is going to equal to uv, which is ex. Let me do this, and let me get a normal eraser. So yeah, here we go. So what we're going to do is, this is negative ex cosine x minus v, so it will be v cosine x du, which is ex dx, sorry. So now what we did is we're stuck again. So what we do is we repeat. We're going to say our u is going to equal to ex, so our du is equal to ex dx. And we're going to do the same for dv, where our dv this time is cosine x dx, and our v is going to be simply sine x. And if we want to write it out, this is going to mean that our ex sine x dx is going to equal to minus ex cosine x, and this is going to be plus uv, so plus ex sine x minus v du, so this is minus sine x ex dx. And you start thinking, well, are we getting anywhere here? We're just stuck. But actually no, if you take a closer look, you're going to notice this important step that solves the whole thing, that this and this are exactly the same. Now if we want to take them to both of the same side, we're going to have 2 into ex sine x dx equal to minus ex cosine x plus ex sine x, and I forgot the x here. And now if we want to, and we are actually trying to find this integral, which is ex sine x dx, and this is simply going to be half this sum, ex cosine x plus ex sine x, and don't forget your plus c, and that would solve your question.